So we raise some amount of money to produce some results, right? And so we we can't afford the exploration that happens in a lab. Lab output is all about producing insights. Our output is about delivering on the roadmap. And so, if you want some kind of control on delivering on a roadmap, and this roadmap is actually we're going to build this revolutionary machine, you don't have that many levers that you can actually control. And so, building a process that enabled us to make sure that the roadmap was actively being worked on was a key thing.
Welcome to Deep Dive, the podcast where we will explore the ins and outs of managing deep tech products. I'm your host Ravi Sundaram, and we'll be talking to product leaders about the intricate and innovative process of transforming cutting edge science and technology into products that shape our future. Join us as we learn from these industry leading experts on how to turn groundbreaking scientific discoveries into tangible real world experiences. Today, we have the pleasure of hosting Blaise Vignon, Chief Product Officer at Alice&Bob, a French company that's building quantum computers. Blaise's journey is a testament to the intersection of technology, business, and education. Trained as a chip designer, he honed his skills at NVIDIA when it was still in its infancy. Following his stint at NVIDIA, Blaise transitioned into Microsoft, where he immersed himself in the realm of business development, adding another dimension to his skill set. Drawing from his diverse experiences, Blaise ventured into product management, specializing in technical products, particularly in the domain of artificial intelligence for advertising, before jumping headlong into the deep tech world of quantum computing. Blaise's contributions extend beyond the corporate realm. He's also deeply involved in education, sharing his wealth of knowledge as a product management instructor at EPITA, a leading French computer science and engineering school. Welcome, Blaise. It's a real pleasure to have you, and looking forward to speaking to you.
Thank you, Ravi. It's a nice introduction. Thank you so much.
Excellent. So maybe we can get started already. Based on your article, you paint a clear need to bridge scientific research and engineering in deep tech. Maybe for listeners who are less familiar with quantum computing, your field, maybe you can elaborate why such a different approach is needed and why can't we use the popular Agile or other stage gated approaches in tech?
Yeah, where do I start? So we build quantum computers. We want to build quantum computers. And the process of building quantum computer is a fairly complex one, and also one that involves many skills. You want to design a chip, you want to build a chip, so you have microwave engineering and you have nanofab, and then you want to test a chip, and that's where physics comes in. And then you have a whole host of other engineering skills that are involved into building this chip. And if I don't name them all, I will forget one, and people will hate me. But you've got software, you've got cryogenics, and everything. And obviously you have this huge complex system, and you want to optimize it because that's what we do. We want to optimize things. And so when I joined Alice&Bob, I looked into the literature. How do you do such a thing? Is there such a thing as Agile for hardware development? And the literature has a couple of things on Agile for hardware development, but the truth is, Agile in itself, if you look at the history, that's something I discovered when teaching. Agile in itself is the implementation of a broader idea, which is Lean, and Lean is for hardware development. And so, in a sense, it doesn't really make sense to go from Agile back into Lean. What makes sense is to start from Lean.
Sure.
And reinventing Agile for hardware when Lean already exists is kind of a detour. And Agile also comes with a reputation. And while most of people at Bob are not from the software world, they hear, they read, they're friends. And I didn't want people to be skewed by whatever perceptions they might have of Agile, be true or false. Especially, I was very worried about the bureaucratic reputation that sometimes Agile has acquired. So we decided to build processes, and to do that, to go back to lean first principle. The thing is, I'm not a lean expert by any means. And so as we reinvent this process, I don't want to say we have reinvented it, but we're reinventing it every day. We often have to go back to the first principle of lean, um, and there are,
Maybe
yeah.
maybe for our audiences, could you what is the first principle of lean? What is the core principle of lean that you used for this process?
Well, lean is all about minimizing waste. So you need to identify
Hmm.
what is waste, and a couple of principles are used to minimize waste. Um, Waste in our case is wasted engineering time.
Hmm.
And a couple of things you might want to do to minimize waste. You want to adopt a pull not push principle. So we
Hmm.
have this cycle, right, where we design chips, we build chips, we cool chips down. It doesn't make sense to have a huge backlog of chips being waiting to be cooled down, right? So you want a process, for example, where people want to measure things on chips. They have this um, moment in time where
Hmm.
they can tell to the people who design the chips, I will need this chip, right? So we have this pull process as opposed to this push process.
Sure.
So that's one very important principle of lean. Another very important of lean is rapid iteration cycle. So being able to observe what's happening in the pipeline, and that's what I wrote about in the blog.
Hmm.
How do you measure your pipeline? And when you measure your pipeline, what you first want to do is you want to define your pipeline. What is it
Sure.
you're actually doing, and what are the key steps?
Hmm.
So that's another very important part of lean, and a third very important principle of lean, I think, for us is you want the process improvements to come from the people actually involved in the process. So you want the continuous improvement to not come from above, but come from the people actually doing the work. And that's I will say it, and maybe it will be taken out of context, but lean was invented to build cars, right? And so when we said that, it was very very um, when we invented lean, when the Japanese invented lean, the idea that the process improvement had to come from the workers was basically you have to trust the factory workers, and that was kind
Of
of
course.
revolutionary. We don't deal with factory workers at Alice&Bob. We deal with very highly trained people. So this is maybe less revolutionary, but same principles apply.
Excellent. Yeah, we'll come back to the people in a bit as well, but this is already very fascinating.
Mm.
Maybe maybe a quick word on why did you think why was it important for you at Alice and Bob to change the process that was there, or even incorporate? Maybe talk about the why.
Yeah, I mean, the entire idea is we are a private company. We are funded by private money. I will turn off my email system. Sorry.
No worries.
Um, and so we raise some amount of money to produce some results, right? And so um, we we can't afford the exploration that happens in a lab. Um, Lab output is all about producing insights. Our output is about delivering on the roadmap. And so, if you want some kind of control on delivering on the roadmap, and this roadmap is actually we're going to build this revolutionary machine,
Mhm.
you don't have that many levers that you can actually control. And so, building a process that enabled us to make sure that the roadmap was actively being worked on was a key thing. And so that's why it was very important. Um,
Excellent.
and I will continue on your question if you allow me,
Please.
which is not only the why, but also um, what made it easy. I don't know if you were going to ask that, but I will answer it anyway.
Please do.
The very important thing I think about Agile that people sometimes underestimate is its capability to impose some kind of rhythm in a company. So in a company that doesn't use Agile, it's I don't know if you've ever worked in one. It's very hard to understand if you're late early or if you should rush or if you can chill, right? and
Hmm.
and and what Agile brings you is this 2 weeks rhythm, right? Typically sprints are 2 weeks. I know people are
Sprints.
experimenting with different things, but and
Hmm.
and when I joined Alice&Bob, I was thinking, okay, what are we going to find that's going to give us a rhythm? So there's obviously the strategic planning rhythm of the company, be it week, be it quarterly or semi-yearly or yearly. So that's an easy one. But what do we have that's shorter? And the nice thing about a company about Alice&Bob is
Mm-hmm.
that Alice&Bob already has a rhythm, and that's very specific to us. But
Mm-hmm.
whoever is listening to that, maybe there's something like that in your company. But to us, it's the rhythm of the fridges. So um,
Mm-hmm.
our technology is built on chips that we cool down to 10 millikelvins. And to cool down a
Mm-hmm.
chip to 10 millikelvin, we have this very impressive fridges. I won't go into details on why they're impressive, but they're a fairly amazing piece of technology. And it takes 2 days to bring a chip to 10 millikelvin from room temperature. And so basically, we do that on weekends. And when I joined, we had a couple of fridges, and we had this rhythm where we do it every other weekend.
Mm-hmm.
And so that was the heartbeat of Alice&Bob already. I didn't invent that. And so it was kind of easy to leverage that. And so all these ideas that I was talking about in terms of lean, in terms of pull not push, and
Mm-hmm.
everything else, how often do you um, improve your process and everything?
Mm-hmm.
We could map onto this heartbeat of the company, and that that makes things very easy because in the end, um, I mean, I don't want to say it's one. I definitely don't want to say it's one, but
Sure.
a big part of the tension here is you want to implement a process, but everybody's worried about bureaucracy and meeting.
Of course. Yeah.
So you want to implement this process, this communication process, where you don't want to increase the coordination costs, and everybody understands that to cool down a fridge, you have to meet.
True.
What chip are you going to put in? How you're going to cable them and all that. And so
Mm-hmm.
that was kind of my free lunch way into it. We could build these processes. We could build these processes kind of free in terms of bureaucracy costs, and we just had to map these principles onto the existing processes and improve from there. So no big bang, I
That's
guess, is what I'm saying. Mm.
No, that's great. I think, and if I could play back the why, which is
Mm.
essentially it for you, it came from two pieces: the fact that you were a private company raising capital, and this is a capital-intensive development cycle, and you wanted to optimize that. And secondly, you wanted to implement processes using the inherent rhythm of the company that exists around the long cooling times that you need for your hardware, for your testing, and so on. So that makes sense. You've integrated both these things nicely to get a nice process. Maybe we can use that as a segue to maybe ask you to briefly explain what is the process. How do you what is your I've read your 4 stage process. Maybe for our audiences you can explain how that works, how your team implements it today.
Yeah, and for people in the semiconductor field that are listening to this, you might recognize it. But basically, you have an ID for a new chip that you want to test. You design the chip and you simulate it. Then you fab it, and
Hmm.
then you test it cold in the fridge. And out of those results, it worked, it didn't work, and you loop around. So you have this kind of loop: ID, simulation, fabrication, experimentation.
Hmm.
It's a couple of things about this process. It's first is what I'm explaining is very high level.
Of
Um,
course.
and as many of these processes, every time you drill down, you have branches and sub processes and all that. And the second thing is it's amazingly short. I'm assuming that most people in the deep tech field have cycles like this, and that they are typically months or several months long.
Hmm.
Um, when I joined, the entire process could be run in a month, and I think it still can.
Hmm.
That's, I mean, there are several reasons for that, but that's kind of joined to the industry we are in. We are working with systems that are fairly complex, but can be built with relatively accessible hardware. I'm not saying it's easy, right? But
Sure.
it can be built relatively with relatively accessible hardware, and so this process is very short, and um, that's something. I mean, to be totally transparent, that's something when I was contacted by Alice&Bob about this position. That's something that made me decide, yeah, this is a company worth joining, because
Mm.
you have this process which is short, and if you can maintain that, that's your that's the velocity of your ideas, right? So if you can take an idea from an idea to an experiment results in a month, you can test 12 ideas per year multiplied by the number of slots you have, which, we have 4 fridges, so depending on how many chips you fit in a fridge, and that's a big number of ideas. and, and
Absolutely.
and and as I said, we have this money we raised to achieve this particular milestone, and
Mhm.
that's, I mean, my physicist friend will hate me for saying that, but it's really a matter of how many ideas can you test in a year.
Sure.
so
So
and, and,
it's
and so as you said, I have an electronics background. This cycle in electronics is 2 years, or a
of
year and a
course.
half, right? And here you have this cycle which is a month, and not only do you have this cycle which is a month, this company that was trying to hire me at the time, they already knew that this was a key value that they had, and they wanted to maintain it. So they knew what mattered, and so this is something that I've been striving to maintain. Not only is a quality assurance of the process, is this process, efficient and everything, but also is it fast?
That's a very interesting point, because you're right. In the semiconductor industry, where I come from as well, these cycles can be long, because you also have a tape out process, and then you fab, and it takes. I think the crux that you mentioned is very, very interesting, in the fact that you have accessible, you can fab it in fairly short amount of time. It is complex, but it is accessible, which is what is driving the power of this process. Very
Exactly.
interesting.
And as the chip get bigger, it's actually it's something that we're monitoring. Can we build bigger chip in the same process time? And obviously, the answer is no, unless you
Of
work on it.
course. Of course, but at
Yeah,
least you get to that point faster, and then it's a more traditional life cycle than this
exactly.
kind
Yeah.
of development line. Very interesting, very interesting.
Mm.
Well, maybe a little pivot into the other aspect of any sort of success of a process, which is the people who implement it.
Mhm.
And I draw your attention to the struggle that you expressed between free spirited scientists. I was one
Mhm.
as well at one point, long time ago, and running a process like a factory.
Mhm.
Maybe you can to make it more tangible. Can you give a specific example of where you observed this challenge, and how did you maybe uh, implement it in terms of getting across this challenge?
Yeah. And so I was thinking about how to go about it, and yeah, here's what I think. Um, here's what I think. Here's what I want to share.
Please. Mm.
um, when you're working on when the physicists here at Alice&Bob are working on quantum physics, they are encountering new phenomenon, daily, maybe not weekly for sure.
Mhm.
And the temptation is great to explore every single one of them, and so you end up with this fractal tree of ideas, right?
Sure.
And there's a lot of value in that fractal tree, especially a lot of branches that look very promising.
Mhm.
And we and sometimes there are like small branches, but sometimes they go back all the way to the root of the roadmap.
Mhm.
So at the root of the roadmap, 2 years ago when I joined, we had two technologies we wanted to explore for cat qubits,
Mhm.
and one of them had better performance, but we didn't see how we could scale it, and the other one had not as good performance, but we knew how to scale it.
Mhm.
And they were both producing amazing physics, and especially the one with a better performance obviously was producing better physics. And one thing where I contributed is explaining that branches needed to be called.
Mm.
And that's painful. This branch is somebody's PhD thesis, right?
Absolutely.
And that's where I think it worked. not only because the founders of Alice&Bob have a very high discipline on this kind of
Mm-hmm.
thing,
Mm-hmm.
but also because we work closely with academic partners, and so these branches that have interesting physics but will not bear any fruit can continue living in their labs, and so that kind of reduce the pain. But this is the kind of things you have to manage, I think, as a product manager in such a field. Uh, how do you consciously call the tree
Of
of
ideas.
exploration? And so I think that's one thing we are doing fairly well now at Bob in terms of yeah, this first time around maybe I was pushing more to do some of the culling, but now as we um, have other processes that are not in the block, but where we, based on the OKR method, I mean, we haven't invented anything, right? But the OKR method is now very well deployed within Bob, and that means that every single team leader has more incentive to be aligned and decide what's to explore and what's to explore. And yeah, that's a nice. Um,
That that is
Maybe
perfect.
progress is not the right word, but and it's a nice state for what we want to achieve. It's a nice position for us to be in. Mm.
No, that is absolutely brilliant because I think this is a challenge that every product manager in sort of deep tech would face in terms of how do you not stifle the ideas. Of course, that creativity is what's going to produce the things that would move the tech forward as well. And I think what you said about making sure the value of the idea is captured via academic collaborations or spinning it out into that is very valuable, and keeping the discipline on the core technology development while making sure that the idea is given its value. That is absolutely brilliant. Great to hear that that's working. Um, Maybe you mentioned something, and as we ended, so you said it's working fairly well. Maybe we can talk about those things. How do you know it is working fairly well? Do you have metrics? Do you watch out for something? And if and a follow up to that, and I'll ask this because if you miss the metrics, and especially in deep tech, you could go into analysis paralysis of why things failed. How do you manage these two things? So metrics, and how do you manage the failures?
Um, yeah, I'm going to be less definitive on those things, but I'll give you my take,
View,
right?
yeah. Sure.
Um, how do we know we're succeeding? I think the first principle is first do no harm, right? I mentioned that the reason why we had early success is because we didn't increase bureaucracy.
Hmm.
And at the moment, there's a perception that bureaucracy increases, I receive
Hmm.
Slack messages. And so keep, I mean, hopefully I'm not too out of touch that people still reach out to me.
Sure.
Um, but uh, but yeah, the first thing I'm keeping a close tab on is are the meanings that we use to run this process efficient and producing value for everyone. And that's
Hmm.
something that I I I, I try to pay close attention to. Um, the metrics we use, the thing is, we're still a fairly low volume process, right? We only do a couple, couple of tens of thousands per year, and so
Hmm.
everything you want to measure that we do measure, such as lead time for designs, lead time for fab, and everything.
Hmm.
Those end up being fairly noisy metrics because anybody who ends up sick or on vacation or somewhere for we didn't have the product to finish it or something, you end up with very very noisy metrics. They're still informative, of course, but you have very noisy metrics. So we also keep track of metrics such as how many people did we impact with process improvements, with tool improvements, stuff like that, making sure that we actually have appetite for whatever we are building, because
Hmm.
all the process is getting tool as we build it, right? So getting track of tool usage is also a good way to keep track of adoption, and adoption is a good metric of usefulness, right? People won't adopt a process that's not useful. um, you also asked about the analysis paralysis. um, without betraying too much about what we do, we might have uh, gotten a little bit too far in the other direction.
Okay. Speed over
Yeah.
understanding the root cause. Okay, interesting.
And there's this kind of momentum that's right now coming back. So we
Of
haven't faced
course.
that problem yet,
Very
but
good.
I'm ready to tackle it whenever it happens.
It's a good problem to have, as they
Yeah.
say. No, that's brilliant.
Thank you.
Excellent. This has been fascinating. Maybe we pivot a little bit our conversation into the skill of deep tech product management itself.
Yeah.
Maybe we start with, can you give an overview of the breadth of your role within as a product lead product manager within Alice and Bob? What are your responsibilities?
Um, yeah, it's a hard question. Unfortunately, I've been struggling with that a lot. I've been hired to do a couple of things, and they were summed up by the idea that we need to get Alice and Bob out of the lab and into a
Okay,
product. So how do we get access for people to our chips? And that's something that's not covered at all in the blog, but it is in coming one in terms of
sure.
how do we build access for our chips to our quantum computer. And
Hmm.
that was the main thing. And I also met a couple of people in the product management field, and I asked them what it is to be a product management in deep tech. And one
Hmm.
piece of advice that was given to me by Ed Murray, um, whom I'm hoping we get to interview in this podcast as well,
Sure.
formerly of Verily at Google. He
Hmm.
said you need to serve the PIs. So these people, PI being a science term for people leading a science project,
Hmm.
those people, they know where they want to go, and you need to basically make the road smooth. And so
Hmm.
that's also what I've been doing, or trying to do. I don't want to claim I've succeeded again, but that's the role. Getting that it's it's typical product role, right? Product was invented by meshing together the execution part and the marketing part, right? So how do you go to market as fast as you can? And it just happens that in our case, in the deep tech case, the execution and the market are much further apart than they are in the traditional software case. And so as we are reinventing product management for these deep tech companies, we have to straddle um, a wider gap. But the crux of the job is still the same, I think, which is how do you get a a quantum computer to market as fast as you can.
Yeah,
So that's the breadth of the role. Yep.
this resonates with something what some of my mentors told me as well early on, which is essentially one of the key roles of a product manager in deep tech is to remove roadblocks so that you're going towards market in product in a smooth way. And it gets complex, as you said. There's many branches that develop that you need to cull and all of that kind of stuff. So excellent. It resonates with me. Your message as well. Maybe on the same lines, for people who want to break into deep tech product management, what do you think is the number one non-technical skill that they can draw on or they should have? What is your view on that?
I like that you narrow the question to non-technical, because otherwise it just would not be
Otherwise, we
answerable.
can go further.
um, I think the number one non-technical skill is coaching. Um, the
Mhm,
reason I am going to coaching is we work with smart people. These people could have done any
mhm,
job they want. They chose to do
mhm,
this, but they could have learned anything, right? And we have so much more leverage by getting them on the right path and the most efficient way of doing things, and the best practices, than
mhm.
by stepping in their place. And
True.
not only do we have more leverage, we also have more buy-in, which is a very important thing. Um, uh, it the product managers have no power anywhere, but nowhere do they have less power than deep tech companies.
Sure.
And so the only power we have is persuasion and a coaching posture, a coaching attitude gets us so much further than uh, a more directive one. So yeah, coaching with everything that comes with coaching, right? Empathy, listening, and everything. I think is the main one.
Brilliant. Yeah, no, it also is extremely important in the sense in any product management role, but in this particular, in deep tech particular, because this is more longer life cycles, you need to sustain the empathetic attitude and get by in that way. That is very, very true and very sage advice. All right, we are coming towards the end of our discussion, so let's just wrap up with something light, which is for for people listening to you, for people trying to get into deep tech. Do you have any book recommendations that people could that you've enjoyed? Maybe something to put in my empty bookcase behind.
Yeah, I knew you were going to ask that question. I was wondering, and there are some, there are many books. And going back to first principle, right? Going back to first principle of lean. I sometimes I'm surprised by how many project managers haven't read a book called The
Any-
Goal.
Mhm,
You seem to have read it. The Goal is a book which is written like a novel. It's not like a business book,
mhm.
and it gets you to the core principle of lean in like 150 pages. And
Ex-
everybody should know the core principle of lean. There's no excuse not to know them. And
ex-
this is a short novel, so people should have read it.
ab- Absolutely. Well, there you go. Goal recommended by Blaise. Absolutely on the list. Excellent. And maybe one deep tech area that is not yours that that you're really excited about.
Yeah, I discovered this field through my kid. My kid is studying microengineering and especially
Hmm.
implantable implantable chips.
Hmm.
Um, I didn't even know this. I mean, do you even know what they do over there? It's crazy. It's, so yeah,
It,
I
it,
wish I had known. I wish I had known. I probably would have joined him there. Yeah, so there are
impl-
a couple of companies like either drug delivery or I know we probably will interview somebody from a robot company for brain surgery and like everything
Excellent.
that comes from microengineering to health. That there's a lot of potential there. It's just
Abs-
fascinating.
I agree. It is a whole new world of complexity, but it's so fascinating. And absolutely, you're right. We will have somebody from one such company in one of these episodes. So absolutely. Very good, Blaise. This has been wonderful. Maybe for listeners who want to learn more from you, what is the best way they can get in touch with you?
Yeah, I'm fairly responsive on LinkedIn, or you can just send me an email. My first name is on screen. Last name is Vignon, so Blaise.Vignon at aliceandbob.com, alice-board.com. Yeah, you'll find me
Brilliant.
easily. Yep.
Excellent, Blaise. This has been wonderful. Thank you very much for your time and all the best for your continued success.
Thank you so much, Ravi, and thank you so much for getting this, you know, knowledge sharing started. Lots of value, I think, for us first, and everybody would join the industry eventually. I think you're doing God's work here. So thank you so much.
Thank you. It's all about the learning. So thank you
Yeah.
very much and all the best. Take
Thank you.
care.
Bye.
If you like that conversation, please subscribe. You could also engage further by joining the Deep Tech Syndicate Substack and Slack channel via the link in the show notes. You'll be tapping into a network of the brightest minds in deep tech product.